Hey everybody, hope you had a great weekend. Today we're going to start on dilations, which is section 2.7. If you had any questions about the area or perimeter of similar figures, which was 2.6, please make sure you email somebody and set up a Google Meet so we can discuss those concepts a little further. So to start off today, I'd like you to do the do now here, which is to draw a triangle with the given vertices and then multiply each one of these numbers by 4 and then draw the new triangle. Alright, so I want you to draw this, multiply every single one of these numbers by 4 and then draw the new one, and then try to decide how the two are related. Alright, so if you pause the screen and do that. Okay, so I've gone ahead and drawn the original figure. What I'm going to do now is I'm going to multiply each one of these vertices by 4, which gives me 0, 4, 8, and 8. And 8 and negative 4. Alright, so now I'm going to go ahead and graph all of these points. Alright, so here's my new triangle after multiplying all the vertices by 4. So now they want to know, how are the two triangles related? Well, these two triangles are similar. Here, these are two similar triangles. So the angles are the same, it's just that this one is bigger than this one. So that is how these are related. They are similar triangles. And that's what we're going to talk about today. That's what 2.7 is all about. The transformation of making a triangle or any shape bigger or smaller, and what that is in relation to the original or the image, the pre-image, to the image is known as a dilation. So a dilation is when our image is similar to the pre-image, it's just either larger or smaller. So if we look at A, would this be a dilation? Is this the same shaped triangle, just smaller or larger than the other one? The answer would be, for this one, yes. Yes, it is. So this would be a dilation. For B, these two triangles, do they look different sizes or do they look the same size? They look like they're the same size and shape. So when they're the same size and shape, they're congruent. So if they're congruent, it means that no dilation has occurred. A dilation means either this new shape got bigger or smaller than the other one, so this would not be a dilation. Alright, so here is the definition of dilations. Dilations in the coordinate plane. The dilated figure with respect to the origin, multiply the coordinates of each vertex by the scale factor, k. So that means that xy will become k times x, k times y. When your value that you're multiplying all the coordinates by is greater than 1, the dilation, the type of it, is called an enlargement. If the value of k is in between 0 and 1, meaning that, it's like a fraction between 0 and 1, like a half or a third or a fourth, it means that it's a reduction. So it's not going to be negative, it's going to be in between 0 and 1. So if that's the case, that would be a reduction. If it's bigger than 1, it's an enlargement. So with both of them, the transformation is a dilation, it's just the type of dilation that's happening. So let's look at an example of this. So I'm going to go ahead and graph this original triangle. It says draw the image of triangle ABC after a dilation with a scale factor of 3. Okay, identify the type of dilation. So I'm going to draw the original first. You'll see that pop up in a second. Alright, so here's the original, and now it says draw the image after it's a dilation with a scale factor of 3. It says identify the type of dilation. So let's take care of that first. If it's a scale factor of 3, is it bigger than 1 or is it between 0 and the 1? Well, it's bigger than 1, so that means it's an enlargement. So the type of dilation, we'll take care of that right now, it is an enlargement. Well, that didn't work out. There we go. An enlargement. Alright, now what we're going to do is we're going to multiply all of these vertices by 3. So 1, 3 is going to become 3, 9. 2, 3 is going to become 6, 9. And 2, 3 is going to become 6, 3. So I'll go ahead and graph these points so we can see it. Alright, so here's our new triangle. So it was an enlargement, and these were the new coordinates, and this is our image. Alright, so now the next thing we're going to do is we're going to draw this, the image of the rectangle given here after dilation with a scale factor of 1/2. Okay, so the scale factor was 1/2. So is that greater than 1, or is it in between 0 and 1? Well, it's in between 0 and 1, so that would make it a reduction. That is the type of dilation. It is a reduction. So now what we're going to do is we're going to multiply each one of the vertices by 1/2. So -4, -6 becomes -2, -3. -4, 8 is -2, 4. Four, 8 is 2, 4. And then 4, -6 is 2, -3. Alright, so I'm going to draw the image of this rectangle. So all I just have to do is draw this one. So we'll draw that. -2, -3. Just -2, 4. Alright. Alright, and so that is our new image. Now we can also label them with our primes. So -2, 4 was x prime, 2, 4 is y prime, this would be z prime, and w prime. Alright guys, so that's what we're going to do today. So if you could please go to Big Ideas Math and take care of business there. And if you have any questions, write them down on the Google Doc for questions, or you can please reach out to somebody and set up a Google Meet. Alright, well have a good rest of your day, and we'll hopefully talk to you later.